Good evening. Hi everyone. I am Engineering Hibaton from Aqua Energy Expo. We welcome you to today's webinar, Engineering of Water Pumping and Distribution Systems, from design to operation, improving performance and saving energy in swimming pools and fountains. We are pleased to welcome our speaker, Engineering Tabsh Ahmed, Technical Support Engineering at El Musa Trading Company. This webinar is a part of scientific and technical webinar series organized by Aqua Energy Platform, which hosts around 70 online webinar annually. Over the past 3 years, the platform has organized more than 200 scientific webinars recorded and published in our YouTube channel. These webinars cover a wide range of topics in water, energy, sustainability, and artificial intelligence, presented by leading experts and scientists from across the world, from Arab world. More than 25,000 engineering and specialists have attended these webinars, and attendance certificate have been issued to all participants. We invite you to subscribe to our channel YouTube and activate the notification bell to stay updated on all upcoming webinars. You can find the channel link in the comments. We invite you to subscribe to our channel of YouTube and activate notification bell. We will also find the link to Aqua Energy magazine, a monthly publication featuring the latest global news and technicals in water and energy. Finally, we extended our thanks to Engineer Muhammad Khalifa, founder of the Water Technology Experts Forum and Academy, founder of the Aqua Energy Expo platform, the organizer of this webinar. To receive attendance certificate, please fill out the attendance form shared in the comments. Welcome, Engineer Tabsh. We are ready to begin. السلام عليكم ورحمة الله وبركاته. مع حضراتكم المهندسة هبة طه. بإذن الله هنبدأ الويبينار. Engineer Mr. Tabish, can you hear me?
Yes, Hiba, I can hear you. Yeah.
Okay, let's go.
Yeah. Hi, everyone. I welcome you all, and I'm really glad to be a host for this meeting, and I invite you all. I just need a confirmation from your side that am I audible to all or not? Just if we can, Hiba, if we can just open the chat so that they can, or you just give me the confirmation. Am I audible or not?
Not the share screen not appear in this moments.
Yani, am I audible to all the users?
To all presentation not.
Okay, no problem. I'll start. I will just start. So yeah, everyone. Hi, my name is Tabush Ahmed Malik, and I'm working as you can say a mechanical design engineer for in the aquatics
Sorry.
department.
Sorry, can you share the screen?
Sorry.
The presentation is not appear.
Yeah. I know. Just give me some seconds. Like I was just introducing.
Okay.
Yeah, 1 second. Now is my screen visible to all?
Yes.
Yeah, perfect. So hi everyone, my name is Tabish Ahmed, and I'm working in one of the leading, I would say, leading manufacturing and construction and maintenance company for the pools and other water features, namely Al Musa Pools. So today, this webinar will be going about the integrated pumping and water system engineering. We will be covering all the detailed topics about the design, from the design up to the operations. Okay, so let's start. I will give you the brief about the company. Our company, it's about Al Musa. Our company is establishment which is specialized in the design, engineering, and execution of swimming pool, water features, and other wellness features as well. Like if you can say the sauna, steam. We have the other pedicure and any experience showers, steam rooms, a lot of in the wellness sector. So in the previous years of expertise, we have expanded our capabilities across the field of engineering, delivering the innovative and high quality and fully customized aquatic solutions. Have also done different the collaboration with other brand partners, and like some of the names are the Aqua, the Pentier is there, Fludra, and many other channel partners we have. So, the company has started from a very small, what do we say, the enterprise, but in the past. Almost over a decade, over more than 13 years, we have expanded our whole design, and our approach integrates advanced hydraulic design, efficient filtration systems, and modern automation systems, which is integrated to provide a sustainability and a long-term reliability about the project. Moreover, about our scope of work, as I already discussed, that our scope of work includes the jacuzzi, the pools, ice rooms, spa furniture, fountains, waterfalls, sauna rooms, steam rooms. But mainly, our focus is on the pools, the water features, and the wellness experiences. These are some of our partners. The Pentier is a well-known, worldly established brand related to the pool fittings and other pool solutions. Aqua is also a well-known name. Fountain is there. Crystal, Emaux, Boise, Hayward, and Still Pool. And our services in these past more than over a decade, our services has been we are giving the design and engineering solutions. We are having some innovative and tailored designs for pools, water features, and MEP systems, backed by detailed shop drawings. And we are also creating the shop drawings. We are not just in the execution; we are also in the design and engineering part as well. So then we are having the project execution, and we are also in the field of maintenance and repair. Like we have the facility maintenances for the water features and for the water pools, whether it is spa, cold plunge pool, or the hot jacuzzis, or the commercial pools, or whether even an Olympic pools, like for the athletes. So also, we are also into the field of retrofitting. Like if there's already in the field, there's an established pool and any other scopes. So we are also renovating it. Renovation is there, retrofitting is there, and we are providing innovative solutions to make the system more efficient. And also we have the consultation services as well in the field. These are our area of expertise that we have been working from the past 13 to 15 years. We have been in the commercial field, education sectors, hospitality like hotels, and in the residential as well. Corporate offices, governments, medical, and military as well. Like we have the defense project. Recently, we have previously delivered a military project as well. It's totally under the defense. So these are our areas of expertise. This is a successful projects. Like I'm just giving the brief about the Almosa company, and these are some successful portfolios about it, like the previously submitted and satisfactory delivered projects. So yeah, now as our topic is about this integrated systems in the pools and the efficiency system. So first of all, the key point in this whole system is about efficient pumping and water distribution principles. Like what are the actual the principles inside the water feature or inside the pools that are going to be to affect the whole performance of the water feature. So first of all is the pumping, because pumps are the heart of the the future itself. Because like the heart, it pumps the blood and it carries all the nutrients from through the blood to all other organs in the body. And the same way, the pump is carrying the main fluid, which is water, to the water feature, to give life to this water feature, to give life to the feature, like the swimming pools or either the jacuzzis or the this water features, fountains, water walls, or water parks, anything, anything. The pump, we can consider the pump as the heart of this whole feature. So it makes it critical. It makes the selection of the pump very, very critical. Like if the pump is oversized, it will be just definitely costing more money, and it will not be efficient. And if the oversizing means that the flow rate of the whole system is exceeding, or if the oversizing means the total pressure that a pump can add, that pump can push the fluid through, is increased, and it will affect the total aesthetics and total system efficiency. Or another case is like if the pump is it's undersized, if the pump flow rate is not matching, it's not matching the requirements, or the head, the total dynamic head, which is needed, which is the most necessary parameter for a pump to push the fluid throughout the systems, throughout the integrated systems in a swimming pool. So we have for that reason, we can for undersized pumps, the water will not be pushed enough to the distance so that it can reach to the water feature, or it can reach to the swimming pools or jacuzzi or anything. So we cannot have the fun, we cannot have the actual aesthetics about the feature itself. So we cannot see anything. So see how important is the right pump selection. So the pump selection is it's the most critical part. And how we can make it this is the main principle. This is the main principle in efficient pumping. And moreover, there is one more part. Like for example, we have the pump, and the pump is pushing the exact flow rate at the exact turnover, exact total head of the it's exactly pushing the water through the inlets. But what if the number of inlets are not enough to handle the flow rate? That is the another it's really very, very critical in itself as well. Like for the system, for example, if the pump is pushing the flow rate through the channels, through the distribution lines, and at the end of it, see it like we have the end caps, we have the lines which are closed, and we have some of the inlet fittings in there. So what will happen to the whole flow? So it will backflow into it will create a back pressure onto the pump, and pump will start halting. Like it will increase more pressure on the pump, and pump has to overcome this pressure in order to run efficiently. So this will reduce efficiency as well. So the distribution, for the even distribution of the inlet fittings, the main drains, the skimmers, needs to be correctly positioned so that so that yani the pump, the whole system will run without a lag, and will run with utmost will run utmost yani efficiency. Okay. So we have concluded two things here. The two most important principles in designing the pump, in designing the whole feature, is to select a right pump, which is to select a right pump which is having the flow rate matching with the required ones. Okay. And we have to avoid the oversizing, and we have also avoid the undersizing. Although most of the cases, in the cases, the oversizing is the issue, because sometimes we oversize something, it costs the clients the money, it costs him the energy, it costs him the more stronger equipments, items. There is examples we will cover in the next section for the examples about the how it will affect the other equipments as well. So it will, the main cost is the main problem is with the cost. It increases the cost, and also it increases the more energy consumptions. Okay. So we also have to, one more thing in the efficient pumping principle is that we have to ensure that all the pipe sizings needs to be, it should be standard, because all these things, what we are designing from the previous 15 years, they have to be matched with the international standards. The international standards for the swimming pool and spa codes, we have the international standards for them, which are we have other different codes internationally. So what we have to follow, the best we have to follow for them, which is the best in the interest of the client, which is the best for the interest of in terms of the money, in terms of the costing the energy, in terms of making the system more efficient. Another way is the inlet fittings, the main drains, like for the suction fittings and the return fittings. All these fittings should be correctly positioned inside the swimming pool or inside the water feature, or whatever the feature is, whatever the scope is. They need to be strategically installed inside the feature, so that we can distribute the water, we can distribute the flow rate evenly, so that we can reduce the dead zones. Dead zones are those zones where the filtration or the chemical disinfection cannot reach. So in order to avoid these dead zones, we have to ensure that all our fittings are equally distributed, or evenly distributed. I would rather say that they should be evenly distributed, and for that we have an international code that we are following. Okay. Sometimes it is we can find some complex shapes inside the designs, the architectural designs. So what should we do in that? There comes the experience. That how we can manage. For example, we have a pool which is a simple square pool. Okay. For a square pool, we know how to distribute it. There's no big deal. But what if there is a different complex shapes? So for that, there comes we keep in mind the international codes, and also the international standards, and also we keep in our experience comes in. Okay. So next is I already covered, I think, enough of these points, and skimming is also one more important thing, because a skimmer must be installed below the 500 mm of the water level, in the midline of the water level, so that all the debris, all the leaves inside the pool should be collected, and that's another part, we will collect it later. Okay. Now the second most important topic in this is flow and pressure optimization. What does it mean by the topic? By the topic, the literal meaning is the flow rate that we calculated before, and we have a pressure which needs to be optimized within the water system. What does it mean? It means that the flow rate must be it should be matching the total demand of the water feature. For example, we have different the turnover times. Now, what is turnover time? The turnover time is the time in which the whole volume of the water feature, whether it is the swimming pool, in swimming pools, whether it is residential pools, commercial pools, or they are just Olympic pools, or a small pools, this activity for recreational activity for kids, or there is lagoons, or there are the koi pond, or there are the water features, fountains, water walls. All these things, all these scopes have their or have their turnover time. That in how much time, in how much period, this whole water, the volume should be filtrated. How much? For example, we have a water feature. We have a swimming pool, for example, and the total volume of the swimming pool is, let us say, it's 100 meter cube. Okay, it's 100 meter cube. For this, what we have to mention the exact turnover time, the exact turnover. Then in how much time the whole water will be pumped through the filter, through the sand filter, to make it clean, to make it free from the dust, the debris, the sludges, or any other organic matters inside it. Okay, so turnover time is really critical for the optimization of the water systems. Right? So now if for example we have a commercial pool, the total turnover time should be not less than 6 hours. Okay, we can take 4 to 6 hours, because in commercial pools the load is very higher. For example, commercial pools are very big pools. They have the area, they have the total volume of more than 150 to 200, or maybe more than that, the meter cubes. Okay, cubic meters of water. So in order to make this whole water to filter this, we need a lower turnover time. Not totally reduce it to hours, 2 hours, 3 hours, no, but we have to follow the international standards. We have the standards, Las Vegas standards, we have the Virginia standards, we have the international standard codes for public swimming pools and spa codes. Okay, so following these codes, we can find that the total turnover time for these commercial pools, which have the volume which is greater than 150 cubic meters of water, we can simply say that the turnover time should not be less than 6 hours. This is for the best efficiency and to make the water clean. And it means that every 6 hours, the water will be pushed through the filtration system, and it will be cleaned, and it will be pushed forward inside the pool. Okay, so this is really critical. Another is to make a proper calculation, the main calculation for the pipe sizing, and to make it so smooth, to use the pipes which are smooth, which are not opposing the flow of the water, which are less resistant, to reduce the resistance of the water. Because what happens if the flow rate is higher, and if we use the pipe which is of high resistance with abrasive material, it will increase the head, it will increase the pump head. So pump head increasing means we have to increase the pump impeller and vanes, and it means we need a high motor to run that. Okay, so what we are doing here, we are oversizing the pump. We can reduce it by just simply using a less resistant pipe, like a UPVC pipe, or we can use HDPE pipe. But we are going to the pipe which is providing more resistance to the flow. So in order, it is increasing the total size of the pump. Right? So this is the main flow and pressure optimization. So the pressure and the flow, I told in the beginning that these are the main and major parameters for describing a system, for making it efficient. Okay, so moreover we have other, for example, if the pressure in the system increases, it is also increasing the making the system lag. It makes the system lag. So what we have to do, in order to that, we can okay, the question is actually, the let me put it straight. Like, for example, if the pump pressure is higher, I told you before that if the pump pressure is higher, it will increase the size of other equipments like the sand filter, like if we have the UV, or we have the electric heater inside it for the hot jacuzzi, or for Olympic pools. We usually use the heat pumps or electric heaters or gas heaters to make the water hot. So if the pressure is increased, so we have to make sure, that the system is capable, the integration of this pump, the pumping system with other filtration, disinfection, and the electric systems, they need to withstand with this pressure, because otherwise it will be a catastrophe for all the system. It will rupture all other equipments inside the pool, inside the pump room, and it will cost a lot of money. So we need the proper sizing of the pump, the proper sizing of the pipes, the proper sizing of other equipments is really, really very crucial. And moreover, we have yani, in the pump suction side and in the discharge side, we have to monitor the pressure. How much is the pressure in the suction side, and how much in the discharge side, so that we can yani, detect the early causes or early risks, to mitigate them, to just crush them all from the beginning, in order to make it optimized. Okay, right? And moreover, we have to make a regular maintenance for the filters. For example, sand filters, we're having a pressure gauge in the sand filter. If the pressure is increased from the normal operating pressure, we say no, we need to just start a backwash. So we have two systems in there integrated. That is the automatic backwash, and there is a manual backwash. We can use a manual backwash or an automatic backwash, depending upon the client request is. And moreover, we have these flow meters to monitor the flow of the suction side and the discharge side. And one more thing, we can reduce the pressure we can reduce the pressure of the system. It will decrease the sizing of the pump. It will make the system more efficient, cost wise and energy wise. Cost and energy, these are the two major parameters we have to keep in mind. Okay, so minimizing the pressure will reduce the pump size, it will reduce the impeller size, it will reduce the whole casing and the pump size, motor size of the pump. So we are reducing the total cost of the project. We are reducing it. So other systems, like for sand filters, we have electric water heaters or the heat pumps, or we are having the ozones, secondary disinfections, or UVs to kill the algae. So all these things, all these equipments, these sizes will be reduced. And what we are doing here, we are reducing the total cost and total energy consumption of the system. So this is how we are making the system more efficient. Okay. Now, one more important thing is that we have an international standard. It's known as IPC. It's International Plumbing Code. And this International Plumbing Code, and also we have another entity. It's known as Hydraulic Institution, I believe, by the name. Yani, the short name is HI. It's the Hydraulic Institutions. It's the internationally recognized institution. We follow these, and they will provide us the guidance about how we are using the fittings. Yani fittings are also the major causes for increasing the friction inside the system. And increasing the friction means they are increasing the total dynamic head of the pump, which is the most critical parameter. Which time to time, I'm just trying to emphasize this thing. I'm trying to push this narrative that the pressure of the system will be increased. That's the main important thing. So how we will use the fittings? We just avoid the using of the bends, avoid the using of the fittings in the suction side, as much as we possible, that in the suction of the pump, the pipe remains free of bends or fittings. Okay, irrespective of the we have some necessary fittings and valves that needs to be to monitor the flow inside the suction side. But despite from that, there should be no bends or no fittings unnecessarily in the pump suction side. What will it do? It will reduce the pressure of the system, right? So this is all about the flow and pressure optimization system. Miss Hiba, I will just check if there is any text, or you just check any chat there if the audience have any questions or anything. So I will be taking the questions first, then before moving the next slide.
Okay, Mr. Tafish. Everyone, if anyone have any question, please write them in the chat. Just 1 minute. الرجاء من الحضور لو في أي سؤال كتبته في رابط الشات وسيتم طرح السؤال على المحاضر. One question, Mr. Tafish.
Yes,
Yes.
yes.
Amr, can we get the slides?
Can we get the slides? Yeah, sure, no problem, no problem. The whole resources are yours, no problem. At the end
Okay.
of this meeting, I'll be providing all the slides, okay?
Okay, Mr. Tafish.
Sure. I will. Do you want me to share it with you, Hiba, or should I put it in the chat? I believe I cannot.
Yes.
I cannot share it in chat. I'll be sharing it with you. Then later you will share it with the participants. Okay.
Okay, this video will share this on our channel, and we will get you.
Okay. No problem. No problem.
Okay.
Yeah. Sure. So yeah, let's move towards the next topic. We will see what is our next topic. Yeah, this is the main thing we are actually I think Muhammad Hijab is having something. What is he is saying? Because أنا لا عالم اللغة العربية. So if you can translate it.
Do you understand the Arabic language?
لا, I don't. Wallahi, I don't.
Okay, I will translate this.
Muhammad Hijab is saying something.
Okay, he just 1 minute. You want to explain the methods of design swimming pool?
I want to explain of how to operate the station's protection method. Yeah, it's okay, but
He wants to
he
explain.
needs the he needs the sequence of operations, sequence of. I believe this is not our topic today, but I will just start doing it. With I will just give him some insights about it. So before getting inside the plant room, about the filters, what is their size, where we put it. Once again, so in the sequence of the operations, in the safety standards, we have to follow the international safety standards for the regulation of the safety standards and the safety regulations for operating the pump room. And if we need to start the ventilation first, this is the main thing, and start wearing a fireproof fireproof uniform, we will say, and use the safety glasses, and using the safety equipments which normally we call as PPEs. That's a personal protective equipment, like the helmet, the glasses, because anytime if the pressure increases, any equipment can be shattered, and the injury will be there. So these are some parameters that we have to follow before entering a pump room. And the next is like while starting the operation of the pump rooms, first we need to check the system pressure, and we need to check that all the valves are closed. Okay, and then we have to open them so that we will not see any surge inside the system, any pressure surge in the system. So we open all the valves, we check for the leaks, we check for the pressure gauge. They are in the nominal pressures. They are not higher, they are not lower. Okay, lower is good, but they should not be higher. Moreover, then we have to check the electrical items inside the pump room. We need to check the voltage. We need to check the any other fire hazards or any other things like that. So after that, after ensuring everything is good and perfect, then we will start the system. Okay, and then we have to closely and keenly monitor the pressures. We have to keenly check the pressures of the system and also the voltage of the system, because sometimes if short circuit happens, we have to be there. Should be a person who can handle the situation accordingly. Okay, so moreover, Mr. Ahmed, Koshani, I couldn't pronounce it. I don't know. I believe I have pronounced it right. I'm sorry. It's about the filters. What is their size? Where we put it? Yeah, it's a good question. Like the size of the filter, the sand filter, is itself determined by the flow rate. That's why I told you in the previous slide. Let me show you here. In here, I told you that right pump selection, the pump flow rate with required turnover. The pump flow rate is the most important parameter. This is how we determine our filter. Okay, we have in market, we have different sand filters, and different sand filters have their different applications. For example, we have the cartridge filters, we have the sand filters, and inside the filters there are the low rate sand filters and high rate sand filters. What does it mean? We will come to it. I will explain it to you. Otherwise, it's not our topic, but I'm covering the question of from the audience. Okay. Another kind of sand filter, or not a sand filter, but a media filter, it is known as the regenerative filter, which is the most efficient filter in current pool industry that is in use. Okay, so how do we determine the sand filter? Like I told you, the sand filter, we are having two types. The one is the low rated sand filter, another is the high rate sand filter. Okay, what does this mean? What does this rate mean? This rate mean that how efficient is the filter, in how much speed, what is the speed of the filter to clean the water, the rate of the water, the rate of the filter, how strongly it can, how fast it can filter the water. It can clean the water from the debris, mud, sand, slit, or any other impurities, how soon and how fast it can do. That is determined by the rate. The low rate sand filters, they are actually good in the market. Okay, and as per my experiences, the low sand filter, low rated sand filters are good. How we determine the rate for it? We simply check the flow rate. What is our desired flow rate for the pool, for the water feature, or any other scope? Okay, so we firstly take the flow rate, and then we check what is the velocity, or you can say the rate of filtration by the selected model, if we have the flow rate and we have the pressure. For example, we have the flow rate of 10 meter cube per hour. Okay, you can use the GPM as well, you can use the liter per minute as well, but as a metric systems, in metric units, it is, for example, 10 meter cube per hour, and the total dynamic head of the pump is 15 meter, let's say 15 meter. So here we have to select a filter which is capable of handling at least 10 meter cube of flow rate. Okay, and also we have to
we have to make sure that it will withstand the 15 meter pressure from the pump. Like the body of the filter should be must be actually strong enough to withstand with this pressure, with the pressure of the filter, with the pressure of the system. Okay, so we need something. We got two parameters. We got the filter which can handle, which can filter the flow rate of, which can handle the flow rate of 10 meter cube per hour, and also withstands the 15 meter cube, 15 meter of head. Okay, one more important thing in selecting a filter is it's also the most important thing, which is the diameter. How big, what should be the size of the filter. Like we can find the filters which can handle up to 70, 80, 90, even hundreds of meter cube per hour flow rate, and also their pressure is up to 4 bar. Yani they can go up to maximum of 4 bar pressure. Okay, so 4 bar is mostly around 41 meter of pressure, which we don't have in our swimming pools. We don't get that much pressure. But let's say, okay, so which filter we need, how we can finalize this. We will finalize this is by checking the diameter, and diameter is determined by the earlier parameter which I gave in this presentation. That is about the what is the rate of the filter. A low rate sand filter is actually the good for the industrial purposes, and high rate is also actually the low rate sand filter is used for the commercial and the residential pools, but the high rate sand filters are used for the industrial purposes, because the high speed, high flow needs to be it must be filtered quickly. It should not lag the system. It should be quickly, and with less but that will actually affect the backwash of the system. If we go into detail, I believe this webinar this webinar will be shorter, because if we go into the nitty-gritties, into the depth, then we have to cover lot of other topics as well. As you can see, I touched only the filtration, so we came up about the new terms which you cannot find anywhere in the presentation. Okay, so I think the last question I will take from to wash it filters, we use physical method only. We don't use any chemical product, means backwasher. Yeah, exactly. For cleaning the filters, we use only the backwash. We use the same pool water to clean out the debris and clean out the sand, slit, or mud inside, which is contained inside the sand filter. So we use the backwash to use the same water to clean it. Okay, but it is not 100% clean. So with time, every year, 2 year, or maybe 3 years, maybe 3. Yeah, I'm covering the last question about the filter lifetime. It depends upon the manufacturer. If the system is slow, if we have the sand filter which is a slow rated sand filter, the life is very high. The life is very high because it is cleaning the water slowly. The rate is slow, so it cleans slowly and more efficiently, and we can use the backwash and we clean it. By high stand sand filters, they have the limited life, or maybe 2 or 3 years. But other sand filters, and it depends definitely about the structure, and it depends upon the manufacturer, and they are providing maximum of 5 years of the 5 years of the total life of the sand media. The media, we have the perlite, we have the sand, we have the stone inside it. Okay, so yeah, I think I have covered these questions for the audience, and let's move about the main thing, which is the swimming pool water quality. And how we manage them, how we manage. For example, first of all, the question should be that why do we need the water quality management? Why do we need to manage the quality? What things make the water impure? Yani what are the things which makes the water quality, which reduces the water quality? Okay, so for that, we will counter the question like this. For example, a person is going into the swimming pool, okay, and his body is full of sweat. His hair is full of the products, the gel, and he has used the moisturizers or sunscreens or whatnot. Any different products are there in the market that we people are using ourselves to maintain our body. So the person like this who goes inside the pool, it increases the impurities in the water. Okay, type. What will it happen? It will affect the skin of a person. It will affect the body of a person, of a user who is going inside a pool. Okay, so for that, and it will also, in our body, with our sweat, there are airborne bacteria, fungus, and viruses which can come inside the water. So type, to counter these disinfections, what should we do? There is the primary method. There is exactly, biological containments. We have the biological organic containments and inorganic containments inside the water. What should we do? We have to provide a disinfection so that we can reduce the chance of getting disease or from the waterborne diseases. Okay, we have different diseases. And also, moreover, we can see that if the water is stagnated in some vessel, after some time you will see there is some greenish organisms which will be floating inside the water, inside the vessel. What are these? They are the algae, or if we go to the American accent, they say algae. Okay, these algae or algae for the Australians, for Australian accent we say algae. Okay, so for these kind of organisms, to keep them away, because they reduce the quality of the water, they reduce they increase the diseases inside the water, they contaminate the water. So in order to reduce that, we need disinfections as well. Okay, so type, what are the disinfections we have? We have the disinfection. The best till date is the chlorine itself. Not the chlorine itself, but the hypochlorous acid. This hypochlorine, what does it do? It binds with the algae organisms. It binds with the biological and organic wastes. It binds with the viruses, the fungus, the bacteria, and it makes their cell wall to disrupt. It makes their cell wall to disrupt and disperse and rupture, and they finally die. And after their death inside the water, they are still inside the water. Okay, so the chlorine is the main source, main disinfectant which is used to clean the water, to manage the water quality. Okay, how much is that? How much we need? It totally depends upon the usage. Okay, although we have some standards in the international codes, like we have to make the chlorine the free. There are more what we can say. There are more terms to this. Like we have the residual chlorine. There is the free chlorine, and there is the total load of the chlorine, total demand of the chlorine. So we are not going into the deep, but chlorine itself, we have free chlorine dosage, which should be between 1 ppm to 3 ppm. Okay, parts per million. So we are using the unit here for chlorine dosing is ppm. 1 to 3 ppm we are using the international codes to determine the disinfection inside to maintain that disinfection inside the pool. Okay, طيب, so chlorine is one agent. Chlorine is one agent to cover the disinfection, to make to the main disinfection agent to use as a main disinfection agent in the pools. Okay, but طيب, where did this chlorine come? Where does this chlorine come? This chlorine comes from maybe it could be a liquid, or it could be in terms of mass, yani mass based, or we have the volume based. But the actual content of this, the salt, is sodium hypochlorite. Okay, and sodium hypochlorite, when it is mixed with water, it forms the hypochlorous acid, and the sodium is it is excluded from the reaction. And what happened? What is sodium? Sodium is a metal. It is a base. When it mixes with water, it forms a base. So it making a base means it increases the pH. Okay, it increases the pH levels. Type, what does it mean? It means the water is becoming more basic. The alkalinity of the water is increased. You got it? So what are the effects of alkalinity? The alkaline materials, they are harsh, like the soap. If we use the soap every day with our hand, with our body, shampooing our scalp with the soap, what is the soap? Soap is the sodium. It's the caustic material. It's the alkaline material. You will see that your skin will be getting dry. So in the same way, if the pH, if the alkalinity of the water increases, our pool scaling, our pool accessories like inlet fittings, main drain, skimmers, or overflow fittings, whatnot, they will start rusting, because these alkaline materials, they are making hard. They are increasing the hardness of the water, which is trying to capture, which are trying to get the ions from the fittings, from the stainless steel fittings, from the main drains, from the pool lining itself, from the tiles itself. Okay, so in order to reduce the alkalinity, as we are already aware about this, that from the beginning, like we have learned, we are all here, I believe we are from the technical background, that if the base is mixed with the acid, what will happen? It will neutralize. Okay, for example, we have the hydrochloric acid. How to make it dilute? We add water to it. Okay, or we have hydrochloric acid. How to neutralize it? We use a base, that is sodium hydroxide, to it, so that we can form the water plus the salt. And salt is not any bad thing. Salt is good, and we can remove it through the pool by increasing the fresh water supply, by providing the more fresh water supply and increasing the circulation inside the system. Okay, so these two parameters are important. Chlorine is used to disinfect. Chlorine is very important. It is used to disinfect as a disinfecting agent inside the pool. It reduces all the waterborne disease risks, but it increases the pH. It slowly increases the pH of the water. To deal with the pH, we have another liquid, which is mostly we are using sodium hypochlorite. Sorry, we are using sodium bisulfate. Okay, we are using sodium bisulfate, and what will this bisulfate do? If the pH is increased, it means the water is becoming more alkaline. Okay, and more alkaline means we have to add some acid. We have to add some acid to this base to neutralize it. Okay, so in order to that, we have to use this acid to reduce the pH. This is the another most crucial water quality management principle. You got it? Okay, طيب. So there are more other things, like for example, there is what do we say, the algae. For example, we have a pool. it also this water quality management also depends upon a system. It also depends upon your water feature, where it is located, where it is situated, whether it is indoor or it is outdoor. طيب, how will it affect the system design? It will affect the system design by, for example, we have the indoor swimming pools. The indoor swimming pools are having less exposure to the sunlight, right or wrong? Okay, so inside pools, like in the basements or inside the gym or inside the residential apartment, we are having the pools which are less exposed to the sunlight. Okay, what is the connection with the sunlight? If the water feature, if the swimming pool is getting in contact with directly to the sunlight, it increases the growth of the algae and waterborne organisms like the amoeba, the paramecium, the algae, the fungus, all over the surface. Okay, what is the another thing? Another connection is that it reduces the efficiency of the chlorine agent to disinfect. Okay, likewise, the acid is diluted by adding more water. In the same way, the efficiency, the effectiveness of the chlorine is reduced by the direct exposure to the sunlight. Okay, so that's why for the outdoor pools or lagoons or koi ponds, we are suggesting, we as engineers in this sector, we are suggesting that we need some other secondary disinfection agents as well, apart from the chemical dosing. Okay, what are these systems? These are the UV, as we all are familiar with this term, ultraviolet light from the sunlight. But another, we have UV. This is ultraviolet sterilization. It is a chamber with a UV lamp. Okay, and the water is passed through this. The fluoride is passed through this chamber, and the UV light is exposed to all this water around the tube. And what will it do? This UV light, it penetrates the cell wall. It penetrates the cell wall of the organisms, the microorganisms which are not visible to our naked eye, like the plantocryptic algae. Okay, these UV lights rupture the cell wall of these organisms, and they actually disrupt and change the DNA of the organism. Okay, what does it happen? What does it makes? It provides us what kind of disinfection? It actually affects the reproduction capability of these microorganisms. Okay, these organisms no longer can multiply themselves. They cannot make the copies of themselves, and they cannot form the colonies. Okay, and another is ozone. Ozone is a critical one. To use it, we have to be very sure about it, because ozone gas is harmful for the humans. If there is any leakage of ozone inside the pump room or inside the pool, and any person inside, any user, whether a kid or an adult inside a pool, consumes it enough in enough quantity, so it will affect, it will even cause death. It will even cause death to them. So we have to be very critical in using the ozone. We have to be very, very, very cautious about it. Okay, but for UV is also, it's a contact based, and UV is okay, it's safe. Right? So these are the levels of disinfection. First, we have covered the chemical disinfection, which is mainly the chlorine, and to compensate for the alkalinity of the water, we use the acid, okay, to maintain the pH of the water. And secondary disinfections, we have the UV, the ultraviolet sterilization, and another is ozone. Okay, and these are the levels how we actually make the water, how we manage the quality of the water. Okay, there are other parameters as well. We have the international codes for them all, like maintaining the pH, maintaining the alkalinity, maintaining the water hardness, maintaining the pH levels, and what is the chlorine levels, hypochlorous acid inside the water. We know it all. We have all the standards and codes that we follow, okay, in order to regulate and make the system efficient. Okay, so this is how we make the water quality management. طيب, if there is any questions, you can ask.
Okay, Mr. Tish, there is some question. There is one question. To wash filters, we use physical methods only. We don't use any chemical burns.
Miss Hiba, I cannot hear you. I cannot understand you. Can you please repeat?
Okay. This question in chat.
It says, I think, do you recommend commercial chlorine or prepare one depending on the pool? Okay. As I can understand this question, I don't know what this brother or this sister is actually asking, but the question is like, as I can understand that he or she is asking for a commercial chlorine, whether you recommend a commercial chlorine or. See, there are two. This question is good. Like, in order to maintain the certain parameters inside the pool, we have to frequently, like in the picture you can see, we have a kit here. We are having this kit and a person, a technician, is actually measuring the how much is the water, how much is the pH in the water, how much we have to add the chlorine or we have to add the acid. Okay, so this is a manual method. Okay, this kind of preparation, this kind of thing is a good practice, but alongside of this, we have to maintain a automatic chemical. We have to integrate an automatic chemical dosing system on which we have to set certain parameters to match our chlorine and match our pH dosings inside the pool, so that all these what do we say, parameters should be met with the international standards. Okay, so for this, I recommend both. I recommend the automatic chemical dosing systems integrated within the system, and also manual checking. Manual kits, test kits are there to check. Okay, and accordingly we can alter the parameters, accordingly we can alter the data inside the system. Right? I hope I have given the answer. Any other question? Algae control in ponds. The source is tertiary sewage. The tertiary sewage. I couldn't get the question. What is algae control in ponds? The source is tertiary sewage treatment water. Okay, for the sewage treatment, I mean, it's the harsh chemicals. As we are actually from the pool industry, I don't know much about the sewage treatment plants, but mostly it is. Just give me a second. I need to put my laptop on power. Just give me a second. Yeah, hello. I'm extremely sorry for the disruption, for the interruption, and yeah, we can go for the sewage treatment. If we have a pond where the source is usually the sewage treatment, I believe there is also the harsh, treating the water with the harsh chemicals, like we have the calcium carbonates, calcium hypochlorites, sodium hypochlorites. We have the HCl, H2SO4, and these are the things. And moreover, there is a new latest technology. There is a latest technology about there is an ultrasonic remediation system. There is an ultrasonic. Write it. I think I will write it in the chat. It is the ultrasonic. Go and look it online. Remediation system, or you can see the unit. Okay. This ultrasonic remediation system, it has a frequency which is matching with the frequency of LG cell. Okay, and what does it do? What does it do? We know naturally, if we can create a frequency which is matching with the frequency of natural frequency of an object, we can make it rupture. We can break down the system. Okay. Now, what's the example? What is the live example of this? As we have seen these opera singers, have anybody witnessed the opera singers? Those are the singers. They actually keep the glass in front of them, and they start making a noise, or you can say generating a voice of certain frequency. They start generating the voice of certain frequency, and when this frequency matches with the natural frequency of the glass breaks down. It shatters. Why? Because natural frequency and the frequency we are matching with it forms a resonance, and due to this resonance, the amplitude of the sound wave, it increases so much, so magnification happens. The glass itself cannot bear this energy, and it ruptures, it shatters down. In the same way, ultrasonic remediation system, we have the ultrasonic transducers. They are emitting the signals. They are emitting the frequencies inside the water, which are directly impinging and penetrating the cell wall of a algae, and they completely make them die. Okay, this is another solution for ponds which are having the algae, and this pond is having the source of water from a sewage treatment plant. Okay, so this is not our topic, like it's not in the pools, but alhamdulillah, I have covered it for the audience. Okay. Another question, the brother or the sister or a brother, I don't know, is asking about the sodium hypochlorite. I read that it is a corrosive agent. Yes. How can we protect our pipes from that? Usually for this system, we are having with the sodium hypochlorite, we are having the acid as well. Okay, so corrosion, actually, that's why we have to also select the piping for the correct piping for this system. That's why we are using UPVC, which is resistant to the corrosion. UPVC pipes, they don't get corrosion. Corrosion only happens in the metal pipes like GI pipes we have. So for that, or the stainless steel pipes, but there should be a coating, a zinc double coating and chromium nickel coating on the pipes if we are going for the metal pipes to prevent it. And also we are using some other water softeners to reduce the corrosive nature of these sodium hypochlorite, so that it will not affect our system. Okay. Now moving towards the last, I believe this is the last topic or not. Oh no, we have another topics as well. This is the energy efficient pool design. Okay. Now this is also the one, as we have already covered a lot about how to make the pool design, or not particularly pool design, but the overall our feature design, how to increase the efficiency. But now comes in the picture the energy efficiency. What is energy efficiency? For example, I will give you just a simple example. Okay, now after that we will move towards the diagram. What is the diagram here? Okay, so first, what is the energy efficient pool design? For example, we in our homes we have the AC, the split AC or the window AC, doesn't matter. Okay, and you can see that we have a remote control with us, and we can control the fan speed. Right or wrong? We can control the fan speed. How we are actually maintaining this speed? How we can regulate the speed? As we are having a single motor inside the AC, single, which is pushing the fan. So we conclude that there is a variable frequency drive. So we can alter the speed. We can alter the speed of the fan by changing the frequency of the motor. Okay. So how does it it is integrated inside our system, inside the water pools. So when the demand of the system is low, the VFDs generate the low pressure, low flow rate, low pressure and the same flow rate, maintaining the same flow rate to the discharge inlets, to the inlets of the pool. Okay. And when our system pressure increases, the VFD increases the frequency and increases the drive of the motor, and it starts pushing the water to the same inlets but with the high pressure, so that it can overcome the pressure. So when it is needed, it will we use the VFDs. When it is not, the VFD controls it. Okay. So in this way, we can, our system's total cost can be managed. We can reduce it to a significant number. Okay. This is one thing. Another is to select a pump which is having the most efficiency in that sector. For example, we have a curve here. We have a peak efficiency point. What does it mean? See, you can see in the horizontal line, in the x-axis, we are having the flow rates. These are the gallons per minute. Okay, this is a flow rate mentioned here. You can see this is the gallons per minute. Okay, and we are having the head in feet, that how much is our pump which is going to push the water through 50 feet of water, 100 feet and 150 feet. This is the curve. This is the continuous curve which is the performance curve of our motor. This these orange lines, you can see the orange line. Okay, and you can check that the flow that we need at a certain point. And you can see that here at 200, from 200 gallons per minute and up to 400 gallons per minute, or maybe in 200 to 300, for instance, you can see that the pump is having the most efficiency. Okay, because through here you can check the efficiency curves. This is the most of the pumps which are enumerated, we have the efficiencies of 80%. Okay, 80%. But most of the projects, they require a pump which is capable of providing a 60% of efficiency. But we can increase it by selecting a pump in its most preferred operating region, which is this region. This curve we can get from the pump data sheet. Okay, and we can select the pump accordingly. This is also the most critical parameter, along with the pump flow rate, the head, and we have to select these two parameters in the pump in a preferred operating region, which is known as the BEP. This is known as a BEP, which is the best efficiency point. Right? I believe this is clear. And also we have also covered that previously we have also covered that the design of the pipe sizes should be good, should be efficient, that it will not increase the friction inside the pipe, which in terms increases the total dynamic head of the pump. Okay, and moreover, we have mentioned that we have to avoid oversizing of the pumps to reduce unnecessary energy consumptions. Okay, and also we have to periodically follow the regular cleaning and backwashing, whichever is required inside the system, like the cleaning of the skimmers, cleaning of the filters, the backwashing of them, cleaning the pool, cleaning the maintaining the pipes, checking for the leaks, and checking the wear and tear inside the valves. Okay, so these are the main parameters which we have to keep in check every time, periodically. And we will come into later. I believe there is a topic about how to maintain the what are the maintenance and operations for the pool. We will cover in that. So any questions? Let me check for the questions. What happens when the pipe of the closure is okay? Any questions? We check for the NPSH of the pump too. Yes, exactly. We check for the NPSH of the pump as well. The NPSH is the net positive suction head. as I didn't cover this much because mostly in our section, in our sector, our pump room is yani our source, the swimming pool is always in the above, yani above the ground, above the basement or above the pump room. So where we don't have to calculate the NPSH, but this is also the critical yani parameter to check the net positive suction head of the pump. And another question is, which is better, an overflow pool or a skimmer pool? Yani it depends upon the it's not nothing, the overflow or the skimmer. It's just about your preference. Usually in our experiences, we are constructing more overflow pools. Okay, we are constructing more overflow pools as compared to the skimmer pools. Okay, but there is an advantage for the skimmer pool that we can reduce the size of the pump room by avoiding and emitting the use of the GRP tanks or the balance tanks, or you can say the surge tanks inside the pool. Okay, but it's better to have an overflow pool. I prefer overflow pools as compared to the skimmer pools, because the surges can be higher sometimes. The bather load inside the water, inside the pool, can be higher sometimes, and we have to compensate for that as well. So it's not risky to go with the overflow pool. Okay. Another question is, what should the turnover time time to be for the? I told you there are different sectors of the swimming pools. If you have attended this webinar from the beginning, I already mentioned that we have the commercial pools, we have the residential pools, we have the kids pool, we have the Olympic pools. Each pool is having its own turnover time, but you can make an estimate. The turnover time is between 4 hours up to 8 hours, not more than that, not less than that. Okay, the window is 4 hours to 8 hours maximum, unless and otherwise the client is demanding from his own side that no, we need a turnover time of 10 hours or more than 8 hours. So that is different. That's different. What is the nozzle shaft was shortened by the filter? I couldn't understand this question. If you can, brother, if you can put it in straight words, I can help you. Okay. Okay, طيب. Now let's move towards another topic, which is integrated water system design and optimization. This is also the most important thing in designing a pool. See here, you can see the filtration system. We have mentioned the design and turnover time typically 4 to 6 hours, but it can go up to 8 hours, which is a standard. Okay, so yeah, integrated water systems and design optimization. So for this we have what are the integrated water system design? It means that when we are designing a system, we take in account all other designs, all other systems inside it. Like for example, we have a recirculation system, we have a a display water system, we have a water treatment system, we have a disinfection system, we have the heating system, and we have the automation and electric systems with it. So all these systems need to be integrated, and each equipment has to be placed in its own position without changing the sequence. Because sometimes I have checked some designs before, in my experiences, where the chemical dosing is used before the heat exchanger or heat pump or even the electric heater. Okay, what will it do? The increased corrosiveness inside the water will affect the heater. So every time we use the disinfection, the chlorine or the chemical dosing inside the pool system at the end of this equipment, at a discharge point, you can say. Okay, just before the discharge point. Why? Because if we start dosing from this beginning of the system, it will make the corrosion rapidly inside all other materials, because they are inside and out, they are made up of metals, and they have the connections through metals, and they are critical. Inside there is no coating for them. there is not much coating, much corrosion resistant coating inside them, so it can make the system, it can make their body, it can make the filtration, disinfection, the heating, the cooling systems to fail. Okay, so we avoid these. This is what integration means with optimization. Okay, so also another thing is, like for example, we are using the ozone disinfection should always be used after the heater, after the heat exchanger, or after the heat pump. Why is the case? Because ozone itself can treat, it has a ozone which inside, that is O3, which is treated, which can be used as a disinfectant inside the pool water. And what will it do? The disinfection, it has its temperature. The ozone is efficient and ozone is effective in a certain range of for the certain period of time in a certain region of temperatures. If we use the ozone before the heat exchanger, and heat exchanger will increase the temperature of the water, all our ozone will be gone. Okay, so we are trying to use it after we are trying to use the ozone every time before the electric heater, so that it will not affect the ozone treatments. Okay, so this is all what we can say about the integration systems and design with optimization. This is with optimization. We have to place strategically all equipments one after another, without changing their orientation, without changing the sequence, right? And now this is a topic about the operation and maintenance strategies for water system. Okay, what are these? So for our continuous circulation management, we maintain a turnover time. For residential pools, it's 6 to 8 hours. For commercial, it's even 2 to 4 hours. And we make to run the pump minimum 12 to 24 hours per day. And it also depends upon the usage. Like for example, in night, there is no bather load inside the pool. So what we'll do, we keep the water, we keep the pumping shut. We shut the pumps, we keep it closed. And in the morning, in the early morning, we will start it again, okay, for the filtration purposes. And another things like there are daily maintenances, like there are certain PMS, like PMS means the periodic maintenance schedule, okay? But this periodic maintenance schedule is also monthly based, it is daily based, it's weekly based, even yearly, annually based, okay? So for this, we have to check all the, as I think I have covered this before, but we will give it, recapitulate this topic again. Daily maintenance means that we have to check for the skimmers. The pump is itself equipped with the pump basket strainers. So we have to check for the basket strainers. We need to keep the skimmers. We need to inspect the pump valves for any leaks or anything, and remove all the debris from the system, from the line. Okay, and for the daily maintenance, for the weekly maintenance, we have to check for the backwash of the filter. Okay, and also we have to vacuum the pool. Vacuum the pool means if the pool's bottom is getting messy, if it is getting sludge or any mud is there, we use our manually we use the vacuum hose, and we connect it with the vacuum point with the suction of the pump, and we clean the pool. You might have seen those people cleaning, the technicians which are cleaning the pool. They are using the long what do we say, the hoses, the long hose to clean the pool. Okay, and also we have to check we have to check for the chemistry of the water. We have to maintain the quality of the water, so that we check the dosing systems and integrate them accordingly. And also monthly basis, we have to calibrate the dosing pumps. We have to check for the sensors. We have to check, because there are ORP sensors, there are CL sensors. They can sense the oxidation and reduction parameters. So we have to check for them whether they are working nicely, whether they are calibrated or not, and whether our whole system is calibrated with our BMS or the SCADA, or you can say any BMS systems. You mentioned them. We have to check for the integration of the. We have to check and inspect for their continuous calibration as well. Okay, So this is all what we have covered till now. It's all about the design and up to the operation of the pool, handing over of the pool. But there are some workflow that I want to share with you about the installation. What are the challenges we face on the site, and how we install it? What is the workflow? First and foremost, I believe somebody has asked about what is the process and how to design it. We'll do firstly when we have to start making a pool or any water feature, we simply start with designing. The designing is a most important and crucial any parameter in this. Okay, what is design? We start developing in-house drawings. First, we need the architecture drawing. We check the architecture drawing and we start making the calculations that how much pump, what are the other equipment sizes that we need inside the system. And then we select the equipments which are best and serving best to our demands. Okay, then we will coordinate with other civil, MEP and other architectural teams to ensure that we are going in the right way. Okay, once we do it, we then prepare a shop drawing. What is a shop drawing? A shop drawing is a drawing which will be executed and followed on the site. Right? Okay. After finishing this shop drawing and selecting the materials and making the design, everything, then we will go to the site and we will start a civil preparation. Firstly, we will start with excavation of the site. We just dug the land and the soil around the location, around the coordinates where we are trying to construct a pool shell. Once the pool shell is, once the shattering is done, scaffolding is done, we start constructing a pool shell. We start pouring concrete and starting waterproofing it. Okay, and then we start strategically. We analyze and we locate our pump room as per the shop drawings. Okay, and inside the shop drawings, inside the pump room and the water feature, we start doing the first fix. Now, what is the first fix? First fix is actually the piping. The first piping, which needs to be piping network, which needs to be connected between the pump room and to the swimming pool or water feature. Okay, we select the pipe, we install them, we install the sleeves where it is needed, and we install the puddle flanges where they are needed, and we start adding the installing the valves and fittings. Okay, now after the first fix, we then go to the second fix. What is the second fix? We install the pumps and other related integrated items like the heaters, dosing systems, filters, all together, and then give the source to them. What is the source? The source, the food, the energy for them is the electricity. So we make the connections, we make the control panels, we calibrate the sensors, we automate the system, and our system is now ready. Now, the last and the most crucial thing is the testing and commissioning. We can go phase by phase, or we can go the final testing as well. We check for the hydrostatic test for the system. We check for the pressure, which is known as a pressure testing, is known as a hydrostatic testing. And we check for the leaks, for pipes, valves, connections, pumps, all integrated systems and equipments. Okay. And we start a trial run for the system, to flushing of the system. It knows as a flushing. Okay, and then we start water balancing. How we do the water balancing? This is the main challenge for the water features and for the pools, that once we do the testing, we have to make the water balancing. Like we have to reach the exact because of the human intervention, there is always a chance to get error inside the system. So to remove this error, that's why there is a standard practice to use the butterfly valves, to use the check valves, and to use other control valves to maintain the flow inside the pipes. Okay, so we check and balance these valves, the openings of these butterfly valves and check valves. We check them. We meet whether they are meeting our desired output, the flow rate, or not. Okay, so for that this is what balancing means. And also chemical dosing setup, we check with our kits. Like here you can see, we check our kits, what is the water requirements, what is the water clarity, what is the water chemistry, and accordingly we can put the parameters inside the system, inside the control panel of the chemical dosing, and we start monitoring we start balancing the whole water chemistry. Okay, finalize. I believe we have now reached at the end of the presentation, and these are some of the projects that we have delivered in our experiences of the past 13 years. So this is the fountains. You can see the swimming pools. This one is jacuzzi. You can see this is the cold jacuzzi. This is the swimming pool. These are the swimming pools. You can see there's a simple rectangular shape, and also there is a complex shape. And these are the water features. You can see fountains. This is a kids play area. This is also fountain. It's a sequencing fountain. Yani we can make a different patterns with it. This is also a great sector in water features. In designing, it is fun to do it. Okay, and this is also a jacuzzi. You can see these are two jacuzzis and a swimming pool here. These are the wellness for our steam rooms, and this is also one of the project. And this is a sauna. As you might have be familiar with these wellnesses. Yeah. Thank you so much for connecting with us. You can connect with us with we have a website. We can connect with there. We have put here our mail ID. You can connect with us through the mail ID as well. If you have any questions or anything, feel free to ask me. No problem at all. Go ahead.
Thank you very much, Engineering Tabish, for joining us today. It was an honor, and we benefit greatly from valuable information here. Thank you for attending, for following along the time.
Course, thank you. It was really, Miss Hiba, it was really glad. I'm really glad, and it was an honor to meet you all. This was my first presentation since I have joined this company, and it was really fun. It was really fun to discuss all these. Although I wanted to discuss more, but the time is the constraint, so we cannot cover all the topics. But surely in future I'm looking forward to collaborate more and to discuss these topics more in the field, because this is a more this is the it is a new emerging field that we need more engineers inside this, so that they can get the insights about it, and we can do some amazing work together.
Thank you again very much, Engineering Tabish. Finally, we send for Engineering Muhammad Khalifa, founder of Water Technology Experience and Firm and Academy, and Aqua Energy Platform, organizers of this webinar. Thank you very much.
Oh, awesome. Thank you so much. Thank you so much for having me. Thank you so much.
شكرا جدا.
So do we have any questions or anything?
هل أحد أي سؤال أرجع كتاب شات، وإن شاء الله بإذن الله مهندس تبش خير حضراتكم.
They are asking for some questions. What about the protection equipment, different valves? I couldn't understand this. Thank you for all the information. You are most welcome. You are most welcome. Inshallah, we'll be collaborating again with Aqua Energy Expo, and we will be covering more topics in detail, inshallah. Looking forward to this, inshallah. Thank you so much, everyone. Thank you so much.
Thank you. شكرا حضرتك. شكرا للجميع.
شكرا جميعا. شكرا. السلام عليكم ورحمة الله وبركاته.
وعليكم السلام ورحمة الله تعالى وبركاته. شكرا جدا لحضراتكم ولاستماع حضراتكم لهذا الويبينار. أتمنى من الله ألقاكم على خير في ويبينارات أخرى بإذن الله تعالى.